Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help teach you how to find the domain of a function, and specifically we're talking about algebraic functions. And when I think of domain, when it comes to algebra problems, what we're looking for is possible inputs. Usually the inputs are x values, so we're looking for the possible inputs that can go into a function. So when you're trying to determine the domain of a function, this is my advice. Start with the assumption of all real numbers, that you can put anything in. And then you eliminate things based on problems that you find. And here are the types of problems that we'll talk about. Problem number one, division by zero not allowed. You can't divide by zero in the real number system. I studied physics most of my life, and even in physics we like to joke that even in quantum physics, division by zero is not allowed. So a lot of times you'll be eliminating things in the domain because of potential division by zeros. The other thing that will eliminate inputs from your domain is you cannot take the square root of a negative number, or a fourth root, or a sixth root, or an even root. These will also give restrictions to domains, and that's pretty well it. So as far as how to find the domain of an algebraic function, start with the assumption of all real numbers and eliminate values that are not allowed based on division by zeros or square root of negative numbers, and again, or fourth roots or sixth roots and so forth. You can't take the even root of any negative number. So I'm going to go ahead and write some functions down, and we'll talk about some examples here. So we'll talk about this function. F of x equals minus 2x plus 3. Another one here, f of x equals 3 over x squared minus 1. F of x equals the square root of x plus 5. And I'm going to go through these examples one at a time, following the little algorithm I talked about here, where we start with all real numbers and then we eliminate based on these observations. Are there division by zeros or even roots of a negative number? So let's take a look at this one. So when we look at this function, there's no fractions. There's no potential for dividing by zero. There's no radicals or roots. So there's nothing we can eliminate here. We can put anything in for x we want. We're going to get a value out. So the domain of this function is all real numbers. Domain equals, this symbol right here is kind of the short symbol for all reals. Now, I'm going to restrict this video to domains only. I'll make another one for chatting about ranges. All right, let's take a look at this one. So we start with our assumption of all reals, and we look to eliminate values of x based on one of these two scenarios here, and we do have a division here. So as we look at this guy, we've got this x squared minus 1 in the bottom. So if I solve this equation, x squared minus 1 equals 0, x squared would equal 1, so x would equal plus or minus 1. And what this means is if x was plus 1, pardon me, we'd have a 0 in the bottom. Division by 0 is not allowed, so x equals 1 can't be in the domain of this function. Same thing with the negative one. Now there's lots of ways to write this out. I'm going to use the shortest possible way I know. The point of this video is not to go through all the different types of notation. The shortest way I know is this. Let's write this all reals except x cannot equal plus or minus 1. So all real numbers except plus 1 and minus 1. Let's take a look at this animal. So here we have a function. This one's got a square root. So if you're going to take the square root of a number, that number has to be positive. Now math-wise, that means that this term, x plus 5, has to be greater than or equal to 0. The equality here is fine with this because it's not on the bottom. Had this been something like 1 over root x plus 5, we couldn't put the equality there because we'd have a division by 0 in the bottom. Right, but it's not. It's just a square root of x plus 5, so this equality gets to stay. And if we solve this value for x, we get x greater than or equal to minus 5. There's our domain right there. All values of x greater than or equal to negative 5. So for example, negative 3 is in the domain. 0 is in the domain. 152,412 is in the domain. But negative 6 is not in the domain of this function. So this was meant to be just kind of an introductory video on how to find domains. I think I'll just leave it at that. Again, you start by kind of like the assumption of all real numbers, and then you restrict things on the domain. You put restrictions on it based on, are there any potential division by zeros or even roots of negative numbers, right? So I hope that this video demonstrates how to find domains for algebraic functions. Have a great day.